Hello future gate toppers, welcome back to ShortGATE. In today's video, we are starting with one of the most powerful and widely used data structures, that's graph. Whether you are dealing with networks, social connections or pathfinding problems, graphs play a key role in solving complex problems. Ready to unlock the world of graphs? Let's get started. What is graph? A graph is a data structure made up of a set of vertices means nodes and set of edges means connections. Graphs are used to model pairwise relation between objects. They can be directed or undirected and can represent anything from roadmaps to social network. Graphs come in various forms, each with its own characteristics and uses. Undirected graph. Edges don't have a direction. Connections are mutual. Directed graph or digraph. Each edge has a direction, indicating one-way relationship. Weighted graph. Edge carry a weight or cost, commonly used in shortest path problems like Dijkstra's algorithm. Unweighted graph. All edges have the same significance. Graph can be represented in multiple ways, each suited for different scenarios. Adjacency matrix. It's a 2D array where the presence of an edge between vertices is indicated by a 1 or a weight in case of weighted graphs. Useful for dense graph. Adjacency list. Each vertex has a list of adjacent vertices. More efficient for sparse graphs. Edge list. A list of all edges and their corresponding vertices. Before diving deeper, let's get familiar with some basic graph related terms. Vertex means nodes, a point in the graph. Edge, a connection between two vertices. Path, a sequence of vertices connected by edges. Cycle means a path that starts and ends at the same vertex. What is the degree of a vertex? The number of edges connected to a vertex. Degrees are in degree and out degree for directed graphs. Graphs are everywhere in computer science and beyond. In social network, web, shortest path algorithms, computer networks. In social network, graphs are used as modeling connections between users, means friends or followers. In web, the internet is a massive graph where each page is a vertex and hyperlinks are the edges. Finding the shortest path between two cities using road network. Here, graphs are used. In computer networks, graphs represent how devices are interconnected in the network. To work with graph efficiently, you need to know how to traverse them. Here are two traversal methods: breadth first search and depth first search. In breadth first search, explores all nodes at the current level before moving to the next level. In depth first search, explores as far as possible down one path before backtracking. Both techniques are fundamental for solving many graph related problems like connectivity and cycle detection. Now see the time complexity. The time complexity for common graph operation varies based on the graph's representation. For adjacency matrix, the time complexity is order of v square, where v is the number of vertices. And for adjacency list, the time complexity is order of v plus e, where e is the number of edges. Choosing the right representation is crucial based on the problem you are solving. Now that we have introduced the basic of graphs, it's time to practice implementing them. In the next video, we will cover graph traversal algorithms like BFS and DFS and how they are used in problem solving. Like the video if graphs makes more sense now. Subscribe to ShortGATE for more in-depth GATE content. Comment below if you have questions or want me to cover specific graph topics next. Stay tuned for more graphs theory concepts like shortest paths, minimum spanning tree and more. Thanks for joining today's session on graphs. They are a fundamental part of many computer science problems, and mastering them will give you a solid edge in GATE. Keep practicing and remember, what every vertex you understand bring you one step close to your goal. Until next time, keep learning. Let's crack GATE together.